Welcome, and thank you for joining me today. I am excited to work through this 8th grade standard digging into systems of equations.
Hi, my name is Tawny Sapp, and I'm excited to spend some time with you today digging into systems of equations. I have taught middle school math from 5th grade through Algebra 1 for 10 years in both Washington and Idaho. One concept that students seem to struggle with time and time again is systems of equations. I am passionate about seeing students engage with and enjoy math, so I want to dig into what this standard really means and how we can support our students. Today, we will be looking at the standard through many different angles. We will begin by exploring the language and vocabulary of the standard, and then we will jump into what it looks like in our classrooms as we teach it and assess it. Finally, we will talk about resources you have that will help you as you teach systems of equations. If you're doing this video by yourself, you'll need a notebook or a journal. If you're watching this video with a team or a colleague, you can just jot down your thoughts or engage in a conversation. We are going to be looking at Idaho Math Standard 8.EE.C.8b, or Solving Systems of Equations. This standard is a big standard in 8th grade. It is the culmination of linear equations and slope, and it is also a direct entry into high school math. Finally, it is part of the broad standard 8.EE.C, or Analyze and Solve Pairs of Simultaneous Linear Equations. Before the traditional standards, systems of equations was generally introduced in Algebra 1. This means that many parents remember learning this in high school instead of in middle school. We will look at the high school standard as well to identify how they are different and why it is important to study simultaneous equations in middle school. The standard states that the students will solve systems of two linear equations in two variables algebraically and estimate solutions by graphing. As we look at the language of the standard, we expect the students to be able to do multiple things. Solve systems of equations algebraically by substitution or elimination, solve systems of equations by graphing, generally using estimation, and solving simple cases by inspection. These skills require a strong background in linear equations, but students can generally use many different entrance points into these tasks. Most of the vocabulary in this standard will have been previously mastered as students are working on single linear equations. The three terms that may need to be reviewed are simultaneous equations, substitution, and variable. Students need to understand the definition of simultaneous equations both literally and conceptually. Simultaneous equations are a set of equations whose solutions are all the points that make all the equations in the set true, and when graphed, the solutions are shown as the point of intersection, also known as a system of equations. Students need to understand that when graphing, you're looking at two lines and looking for where they cross. They also need to understand that they have two equations where one set of numbers, x, y, will be true for both equations. In linear equations, there will be an infinite amount of solutions to an individual line, but unless the lines are the same, only one set of numbers that is a solution to both lines. Students also need to review the concept of a variable. Students who do not understand how variables function in linear equations as an input-output may struggle. For example, with the linear equation y equals 2x plus 4, they need to understand that when you input 2 for x, the output, or y, becomes 8. But when x is 0, y is 4. This standard also addresses 5 of the standards for mathematical practice. Students need to be able to reason, model, and use structure to be able to solve these problems. Solving systems of equations encourages students to exercise flexible thinking and reasoning. They need to be able to analyze the problem in order to justify the best way to set up the equations and solve the problem. Some students will enter the task with a table of values, others will begin by graphing, and still others will jump straight into algebraic equations. Finally, students need to be able to be confident in their structure of a linear equation in order to manipulate it and solve the system. Take a minute to pause the video and reflect on how you have taught this standard in the past. Were there any specific areas where your students struggled? What strategies have you used that were successful with your students? If you have not taught this standard, what do you already know about teaching and solving systems of equations? If you are working with a group, take some time to discuss strategies that you have used in the past to help support students through the standard. This standard is one of the culmination standards of middle school math. There are many standards that build toward it, and it is fundamental in high school mathematics. Students need to have a solid understanding of proportional relationships from 6th grade and linear equations and slope from 7th grade. Both of these standards are significant as students need to be confident in manipulating a single equation and understanding that a set of numbers will make that equation true. They also need to understand how to create an equation from a real-world situation. This becomes more and more important as students advance in their mathematical journey. It is exciting to see students be able to make real mathematical connections as the scenarios become more relatable. However, these real-world situations also become more difficult for students to visualize mathematically, as we will see in one of the examples. Finally, students need to have a well-developed understanding that solving an equation is simply finding a set of numbers that makes the equation true. In high school, students will build on this standard as they use systems of equations to represent relationships and quantities. They will also begin working and modeling equations with inequalities and with constraints. Take a minute to pause the video and reflect on your students. Are there any concepts such as proportional relationships, slope, or variables that your students struggle with? How could this lead to misconceptions around systems of equations, and what could you do to help guide these struggling students? If you're working with a group, take some time to discuss how you could support students who need a stronger foundation in these skills before they are ready to master this standard. In this next section, we're going to be looking at the intent of the standard. The intent of the standard looks deeper than simply what the student can do. It looks at the reasoning and the problem solving the students will engage in and learn from. Part of the beauty in concepts like linear equations comes from the students gaining the skills to think creatively and abstractly when they solve math problems. As we have already discussed, there are several concepts that are important to understand when introducing systems of equations. We have already covered the significance of proportional relationships in solving linear equations. However, there are other concepts that students need to understand in order to be successful. Students need to have a strong background in working with positive and negative rational numbers. In order to algebraically solve systems of equations, students will need to use the distributive property fluently and combine like terms by adding, subtracting, multiplying, and dividing positive and negative numbers. Finally, students should be comfortable with graphing linear equations, specifically in slope-intercept form. These skills will help students become more confident and have a better understanding of what they are trying to accomplish. As math teachers, we understand that the concepts and skills students are learning are much bigger than the task itself. However, it is important for students to be able to see their own growth and identify when they have met an individual standard. When students have fully mastered this standard, they will be able to demonstrate many skills, including calculating two linear equations in real-world problems, calculating the value of two variables from two linear equations, and many others, as you can see from this list. Many of these skills will be demonstrated simultaneously, but some, like solve simple cases by inspection, will be demonstrated individually. When assigning a task for the standard, it is important to identify which pieces of the standard this task is addressing. We will practice this in the next section. The last concept we need to cover before we dive into teaching the standard is misconceptions. There are many misconceptions or understanding errors that a student may make as they begin into 8th grade expressions and equations. The first misconception you may see is students substituting incorrectly or confusing variable terms and constants. For example, if a student is substituting 2 in for x in the linear equation y equals 3x, they may substitute 2 in for the y or simply add 2 to the equation with a result of y equals 3x plus 2 instead of getting the answer of y equals 6. One common vocabulary misconception is to confuse slope and intercept as students are graphing in slope-intercept form. If students switch them, the result will still be a linear equation, but not the line they should be working with. One solution to this is to remind students to check their line by inputting an x value on their line and checking if the y output matches on both the line and in their original equation. This also continues to solidify that an ordered pair is a solution of a linear equation. As you pause the video and read through the remaining misconceptions, take time to reflect on where you have seen students make these errors and how you can scaffold their thinking and help them continue on toward mastery. Students will use the skills addressed in this standard to master many skills other than just solving systems of equations. In 8th grade math, they will use the skills developed to create linear models of problems of the bivariate context. They will then be able to find patterns and form conclusions as they find the slope and intercepts of this data. They will also become stronger in their ability to graph and manipulate proportional relationships. As they enter high school math, they will create, solve, and manipulate systems of equations using inequalities and exponential or even quadratic equations. In high school, there is a growing emphasis on justifying their solution method. While most problems can be solved with any method, table, substitution, elimination, or graphing, the context and setup of the problem often trends toward a specific solution method. As students become more confident in all the solution methods, they will begin to identify when a context fits one better than another. One of the many roles you have as a teacher is to partner with the families of your students to further their education. You may have families who question why their student is learning a concept in middle school that they traditionally see as a high school math concept. Pause the video and write or discuss with your colleagues how you would respond to a family with this idea. In this section, we will look at what the standard looks like in the classroom. By doing the math ourselves and going through the process like our students will, we can see how we can lead our students to reasoning and building connections, not simply to algorithmic solutions that require multiple steps of memorization. Now comes the fun part. Pause the video here and work through the following task. This illustrative math task addresses the portion of the standard solve real-world problems algebraically. This would be a difficult concept to graph without solving algebraically first, and it cannot be solved by inspection because the linear equations do not share the same slope. Resume the video when you are done. This task presents a real-world problem requiring the students to write linear equations to model different cell phone plans. Looking at the graphs of the lines in the context of the cell phone plans allows the students to connect the meaning of the intersection points of the two lines with the simultaneous solution of two linear equations. Students are required to find the solution algebraically to complete the task. Students also need to identify that the last three pieces of information are irrelevant in solving the task. When my 8th grade math class was presented this task recently, the majority of the students were able to derive the equations for the three cell phone plans easily. Then they had the challenge of analyzing those equations to decide on the best cell phone plan. The problem many students faced was how many text messages does the person send a month? Many hit an initial roadblock, and it took them some time discussing this problem before they came to the conclusion that they had to present their customer with a range of text messages to decide on the best deal. Some students began to solve it graphically, like you see here on the left. The issue they found was that without graphing software, they weren't able to exactly find where the line crossed. Other students solved it algebraically, like you see it on the right. This gave them the points where the best deal switches. Below 400 text messages is plan A, between 400 and 805 is plan C, and above 805 text messages is plan B. Most students completed the task when they had a graph and the algebraic solution. The graph helped them make sense out of what they learned from their substitution and algebraic solution. Pause the video and take a minute to reflect on how your solution matched the given solution here. Where was it the same? Where was it different? And how could you encourage students if they hit a roadblock in this specific task? You ready for some more? All right. Pause the video and solve this task. Pay special attention to how you found the equations that you used to solve the task. Afterward, discuss and reflect on how you would scaffold students who struggle to create the equations. Press play when you are finished. Okay, this task asks students to find the amount of two ingredients in a pasta blend. The task provides all the information necessary to solve the problem by setting up two linear equations and two unknowns. There are two similar tasks designed for students in high school, quinoa pasta 2 and 3. These require students to find the information that is explicitly given in this problem here. Quinoa pasta 2 provides the information in the statement of the task in the form of a nutritional label instead of just listing it in the task. Quinoa pasta 3 is a very open-ended modeling task. It poses a question, but the students have to formulate a plan to solve it by looking up the nutritional information online. This progression of tasks helps distinguish between the 8th grade and the high school expectations regarding systems of equations. Each task is similar in method, but in 8th grade, they're given all the relevant information, as opposed to high school where they have to find the relevant information and figure out what to do with it. Students will need to derive a system of two equations from the information in this task. For many students, the most difficult part of this task will be to be using the correct information to create the correct equations. This task also focuses on solving systems of equations algebraically. A quick look at the problem will confirm that the students can't solve it by inspection. And unlike the previous task, students will generally not attempt this task by graphing. The numbers and percentages given would be difficult to graph, and most students wouldn't even attempt it. The two easiest ways into this task are by guess and check or substitution. The student on the right was able to derive the equations, but did not see it as a system that could be solved algebraically. Instead, the student created a table of all the possible quinoa to corn ratios, and they substituted those values into the protein equation to see if they got a true answer, or y equals 4. This method will work rounded to the nearest whole number, but it will not get an exact answer, and it will take a long time. This work shows that the student understands how to create equations from a real-world situation and how to substitute values into an equation, but they are not demonstrating confidence in solving the system algebraically. The student on the left derived the equations correctly and then substituted the top equation into the bottom equation by solving the top equation for Q. This gave the student one equation with one variable that can be solved. The result was the amount in grams of corn in one serving. Then this number can be substituted into the original equation to find the amount of grams in quinoa. Take a minute to pause and discuss what you would say to both of these students. How would you deepen the thinking of each? Share what questions you would ask to help each student move forward. Now we're going to analyze these two tasks side by side. The cell phone task uses a real-world scenario to demonstrate how systems of equations can be used to solve problems. Students will need to use one of many strategies to determine which plan is the best deal. Potential misconceptions can come from students not understanding that different buyers may have different needs. They will also potentially be looking for one solution where all three lines cross. This demonstrates the importance of context in finding a solution. On the contrary, the quinoa task is easy to solve algebraically once the students find the correct equations. The most difficult part of this task is figuring out how to use the information given to create two correct equations. The amount of grams in one serving versus the amount of protein will potentially be confused and lead to incorrect information. Students can derive the equations and then use logic and reasoning to determine if their equations are correct. Pause the video here and read through this slide. Press play when you're done. As the facilitator in your classroom, your goal is to provide students with the opportunity to reason and make connections. You can accomplish this by giving the students graphs of linear equations and facilitating discussions about what they notice and what conclusions they can make. You can also scaffold their understanding of how systems of equations can be solved by comparing slopes and intercepts. As students make these connections, they will begin to reason and predict solutions. The students will need to use reasoning and justification to defend their answers. As they become more confident in the different solution methods of systems of equations, they will become more apt in choosing the most appropriate solution based on the problem and the context. As we look into assessment, we will discuss how to formatively assess students with a rubric in order to move them ahead in their understanding of the standard. To do this, we will use a task from the Idaho Interim Connection Tools Bank. This could also be used as a summative assessment, as well as a method to help prepare students for standardized testing. The rubric shown here was taken from the Idaho Interim Connection Tools for Teachers. It can be used to formatively assess where students are in the standard progression. Many students begin solving systems of equations with both equations written in slope-intercept form. This makes them easy to graph and simple to substitute. Students need to move from here to solving them algebraically using substitution and elimination. The advanced students will be able to analyze and write the equation from a realistic context. The two tasks that we examined both required writing equations with context, but students were working together and had scaffolding from their teacher. We will use this problem from a lesson in the Idaho Interim Portal to assess student work. First, pause the video and solve the problem. How many different ways can you solve it? Are there multiple appropriate solution methods or just one? Which method seems to be most efficient? Using the rubric given, where would you place each of these students? Pause the video and write or discuss how you would assess each student. How would you score them on the rubric and how would you help them move forward? Both of these students were able to successfully find the solution to the problem, but they approached it in different ways. The standard asks students to solve systems of two equations algebraically and estimate solutions by graphing. Resume the video when you have finished. Our rubric gives us a guide as to what is expected by 8th grade students working individually. Student A immediately solved this system by substituting the bottom equation into the top equation. In this case, this is probably the most efficient method, although others do work. Student B rewrote both equations in slope-intercept form and then solved by graphing. While this solves the problem and meets the standard, it is a lower level, and the student should work toward a mastery of algebraic substitution. The student did check work with substitution, but again, they were working with both equations in slope-intercept form. In our last section, we're going to look into resources. There are many resources available to help you dive deeper into this concept as you work with your students.